Hi, in the previous session, right, we have discussed how to create a user-defined package and how to access the user-defined package outside the scope of the package. For example, we have created a package called average. Within that, we have defined a file, and the file rate finds the average, sum and average of 10 numbers. Outside the scope of the folder average, we have defined the target file which called the corresponding contents of the package. Now let us see how to define a package and how to define multiple classes within that package and how to define a main method within the scope of that package, how the main method right accesses the user defined classes defined in the same package. So with respect to the scope of same package, how the package classes are going to be accessible, right? That is a concept. For that, just have a look into right this folder packages. Inside the packages folder, I have created one package, first package, right? In first package, I have defined three classes. One more class, say main class, right? Four classes are defined, right? So just to have a look into, right, these classes alone now. First package, class 1. First package, class 2. First package, class 3. First package, main class. So it seems that we have defined three Java classes right within that first package, and the corresponding main method is also defined in the same package. Now let us see right what I have done inside this class. First package class 1. So what is our package name? Package name is first package, right? Package name is first package. So in all of these classes, hope you understand. In all of these classes, you need to use the first statement as package first package semicolon. Now have a look into this one. First package class 1, then first package class 2, third file first package class 3. In all of these three classes, first package class 1, class 2, class 3, what is the first statement? First statement should be a package statement. Package name. Since our folder name is first package, you need to use the package statement like this. Package, package name. Second class, right? Just to see that. Package, the first package. Third class, say package, first package. So all of these three independent classes are defined within the same package called first package. Now see what actually right we are going to define in each of these classes. For example, public class first package class 1. Public void. Here do we require public? Let me remove public first. Within the scope of the package, public is not necessary. So I have saved the file. Package, first package, class first package class 1, public access specifier is removed. Right? This is class 1. Then class 2, removing the access specifier public. Here, public is removed. Not yet defined inside the class 1. One method is defined, right? For example, void first package class 1 method 1. We are given the message right to test the corresponding message is first package class 1 method 1. Then file has been saved. Second class first package class 2, first package class 2 method 1, first package class 2 method 1. File has been saved. No public access specifier. Then for class 3, class first package class 3, public void first package class 3 method 1. Message is given. First package class 3 method 1. Understand? Three classes are defined, three separate classes. All these separate classes are defined within a package first package. So the first statement is a common one. Package. Now the previous example what we have done, the target type has been returned outside the package name. Now let us try to have the main method within the package name, within the scope of a package. Right? Now I am trying to write another class, say first package main class, right? This is a Java file. The Java file which is also packed as a package, first package, part of a first package. So the target application here introduces the same package statement. So just to consider the content of package, first package, three user defined classes, one more user defined class, a first package main class, which is also defined in the same package. That's what within the same folder file has been defined. Then the first statement of first package main class is also the same package statement as we have done in right, the individual classes, class 1, class 2, and class 3. Package, package name, package, first package. Understand? Do we need public access specifier? Let me remove class first package main class. Here public necessary, right? Public static void main string arguments. System.out.println. First package main class is called first package class 1. What is first package class 1? First package class 1 is the class which is defined in the first package. That is, which is defined in a package called first package. So we are trying to access this class first package class 1 within the scope of same folder, within the scope of same directory, or within the same package. So no public access specifier with respect to the classes are required, because already we have explored that with respect to the package concept, all the classes, instance variables and methods are by default public, right? So all methods, right, all class, all instance variables are public with respect to the same package. So within the scope of same package, the class first package class 1 is directly accessible in some of its classes, right? In any of its classes, right? So inside the main method, first package class 1 and one object is created is equal to new first package class 1. For simplicity, right, I have called uh, first package class 1 dot first package class 1 method 1. Then I have given end of. Likewise, we can try to access the file class first package class 2, right? Here we create one object. For example, uh, let me write here control C, first package class 2, I think. Say this is ffref2 is equal to new first package class 2, ffref2 dot first package class 2 method 1. Likewise, we have the third class, right? The third class is first package class 3, say ffref3 object name, new first package class 3, then object name ffref3 first package class 3's narrator, class 3's method 1. So this way we have accessed the three independent classes defined in the package called first package. Now let me save the file. File has been saved. Now understand clearly What are the contents of first package? Class 1, class 2, class 3, main class. All four classes are defined within the same package, a first package. You just ignore this folder, right? A first package, right? You consider only this folder, right? First package. Because after the compilation, right? Separate bytecode file folder is created here. So just ignore the first package here, right? If you want, right, you can delete this one. Let me delete that folder. Now you don't have any confusion, right? Only the package name is the first package. uh, Four classes are defined. So with respect to the content of same package, we are accessing the classes. No public access specifier is defined. That means we are verifying the default access code, right? In this example. So having these four classes, what is our next step? How to run this target file, because the target file has been returned or has been defined in the same package. So the logic is how to access the target file. That is the concept. Now I tell you, go to the folder first package, right? Enter into the folder first package. Since all of these classes are defined in the folder first package, you need to enter into the first package. Packages, am I right? Yeah, yes. Then the first package. CD, FIRS, PACKAG. First, what happened? Packages, then a first package. Packages, CD, okay, yeah, right. Now, what is our target file? Target file is first package main class. I show you a detailed procedure. Let us try to compile the individual classes. First, carefully understand Java C first package class 1 Java. File has been compiled successfully. Then coming to the second class. What is the second class? First package class 2. Class 2 Java. Second file has been compiled successfully. Then third file, class 3 Java. Third file has been compiled successfully. Then what is our main method class name? First package main class. Java C first package main class Java. Yeah, carefully understand, right? Look into this window. What is going wrong, right? In this file, first package main class Java. That we need to understand clear. What is the error message? But there are no compilation errors in the first three individual files, because first three class files are right independent files in which we didn't access right any other class defined within that package. That's true. Package 1, sorry, package class 1, we didn't access any other class defined within that package. In class 2, we didn't access any other class defined within that package. In class 3 also, we didn't access any other class defined within this package. But in first package main class, we accessed the classes that we are defined within that package. And again, this is also a part of first package, right? So unexpectedly, right, the compile time errors are first package class 1 fref is equal to new first package class 1, right? Symbol class first package class 1 cannot find symbol, right? There is a error message. So first package class 1, this cannot be found, right? Cannot find the symbol. That is the compile time error. But actually, right, what is wrong with this code, or can it justify anything? The code has been read perfectly correct because the package is first package. We have defined some classes. Main class, right, that is a target class, can also have the rights to access the classes defined within that package, right, within that package, because the file has been written within that package, first package. It is also made as the part of first package. There is no error, or there is no doubt, right, to call the corresponding classes, right? This is perfectly a valid statement. So how Java compiler detects, right, the class is not available means, actually, right, to compile the package files, right, we need to set the class path separately, right? So set the class path is equal to, right, percentage, right, the path, right, that should be properly set. By default, right, the environmental variables may be set, right, in which directory, right, say c colon slash jdk 1.8 slash bin. The same settings have been made, right, whenever you compile the corresponding package files. But you should be very careful, right, when you compile the package files. So after you compile the package files, you need to ensure that the class files should have created, understand clearly, class files should have created, and the class files, right, should have created in the corresponding specific folder. As far as this example is concerned, in the previous example, no problem. Since we are compiled the files within that package, and we run the target file outside the scope of the package, that target files compilation file is okay. A target files, right, a target file is running, right, outside the scope of the package. There was no issue. But here we are trying to write the classes, right, inside the same package. So that stage, right, what is actually expected means you need to create a separate folder. Within that, the corresponding package file should be put, right? So if you compile, right, this way, have a look into the screen. Java C first class 1.java, Java C class 2.java, Java C class 3.java. Of course, the bytecode files are produced here, right? You can see the bytecode files. But main method, main class, right? Corresponding to that, no bytecode file is produced because main, right, results in some errors, right? How can it produce a bytecode file? It can't produce a bytecode file. And separate folder should be created to store the corresponding bytecode files. So this stage, right, do not go for using this kind of compilation syntax. Why means there is no specific folder first package within the first package to store the corresponding class files. Let me repeat, there is no specific folder first package is created within the folder first package to hold the corresponding bytecode files of the individual classes. Understand or not? So for that purpose, right, what here to the means, do not follow this style of compilation. Let me delete, right, the actual class files produced during this compilation. We have 1 minute. Let me delete, right, the actual bytecode files produced, right, within this compilation, right. So this is not accepted, since Java compiler, right, should compile these files, and the files should be put in a separate folder, same folder, right, first package, right. For that purpose, you try to use this syntax, Java C minus D. You try to note it, don't forget it. Java C minus D space dot space. What is our first package class? One. Okay, first package class one. First package class one dot Java. Compilation is okay. Now let me show. enter into the first package, what is newly created. Just write for time right at 3:13 p.m. First package, a folder is created. Inside this first package, class 1, bytecode file is created. So don't worry, try to follow this sentence. Java C minus d dot minus d space dot space package class 1 dot java. Can you say right what is minus d? Minus d in the sense that the compilation file should be put it in the same folder, same directory by creating the same directory name. There is a subdirectory name further. The directory name is first package. So minus d which indicates that one more directory, say first package is created under the first package directory. That means minus d, right, which means that one subdirectory first package is going to be created. Within that, the compilation file is going to put, right? That is the meaning of this statement. Strictly follow the syntax, right? This is not even right said in the complete reference book, right? And even you can't find it in somewhere online, right? This is very important one. So Java C minus D space dot space then class name one dot Java. That is very important. Here the space is very important. Likewise, let us compile the second file java c minus d space dot space what is the second class okay first package class 2 first package class 2 dot java. Now have a look into this first package class 2 bytecode file is created. Then the third class name is, yeah, 1 minute, yeah, third class name is first package class 3 java c minus d space dot space first package class 3 dot java. Third package file, right, corresponding to that bytecode file is created, right? You can see the time in which time at which, right, the bytecode files are created. Okay, this is a way to create the individual class files within that package. When you define the main method class within the scope of the package, very important, right? You need not set right any class path and all, right? But actually in our previous compilation here, I'm pointing here, right? The class path has not been set properly, right? So you need to set a class path, right? Using class path, right? Settings. Otherwise, right, this is a simple way to create the corresponding subdirectory, which takes the same name as that of a package name, and the actual package files are, sorry, actual bytecode files are put it in that subdirectory. Then, what is our target file? First package main class. Control C. Java C minus D space dot space first package main class dot Java. Have a look into, right, this compilation. No compile time errors are reported, right? So in case, for example, some compilation errors are there. Suppose OUUT file has been saved. Go to command prompt, recompiling the target file, which is defined within the same package, right? System.out, right? The error message is clearly pointed. So try to follow style, right? When compiling the classes which are defined, right, with respect to the same package, including the main method is defined. So main method, right? Let us recompile it, right? Okay. Main method file has been successfully compiled. Now check the bytecode files produced. In the folder first package, the bytecode files are produced here. For example, let us remove this first package main class. Once again, right? Let me remove. Okay, the first package main class, right? Removing that. Recombine. First package main class. Have a look into the bytecode file folder. Here, this is the way to set the correct path, right? Using minus t space dot space option. Now, first package main class bytecode file has also been created within the same folder. Now, compilation of the individual Java files within the same package are okay. Compilation of main method file which is defined within the same package are also okay, right? Compiled successfully. Now, what is the next step? How to run this Java application, right? Which has been written inside the same folder. That is our question. For that, what you have to do is Java, Java, right? Interpreter name. Then, if you try to write first package main class, I am exploring first, right? The normal style. Java first package main class. You will see this error message because error could not be find or load main class first package main class. Now what happened, the where is actually the first package main class bytecode file is available. First package, understand, no doubt in this. First package main class, this class bytecode file is not available within this folder packages first package. Packages first package. But actually, the that simply I am saying, right? Main methods bytecode file is not available in this first package folder. Instead, main methods bytecode file is available in the sub package of first package, which also has the same name, first package. So here first package main class is there. So for that, right, how to run the code means we need to use Java, Java. Then what is the folder? Folder name is first package, right? Our folder package name is the same as first package. Dot. What is the main method class name? Main method class name is first package main class. So Java first package dot first package main class. I can see the result. What is the syntax? Java file name dot Java, right? Sorry, Java a file name bytecode file. Since the bytecode file is placed in the folder first package, you need to use that folder to run that file. So use first package dot then actual bytecode file is first package main class, so that you will get the expected result, right? So with respect to our order, first package main class is called here. First package main class is called. Then first package class method one, uh, then second package first package class 2 method one, first package class 3 method one, right? So same order. Class 1 method 1, class 2 method 1, class 1 method 1, class 2 method 1, class 3 method 1, then end of it. Hope you understand how Java's default access public is possible, right? With respect to same package, right? So with respect to the same package, right, we have defined several classes. One class can be easily accessible in another class without mentioning that, without mentioning something, because only one thing, all classes can have same package statement. All classes are part of the same package. package name. So simply you can access any class within that package, within any other class, right? So one class can be accessible in any other classes within the same package name. So by default here, public class first package class 1, public void first package class 1. That means default access copy is written public with respect to the same package. Explicitly, you need not specify the public access scope. Hope you understand the previous example, right? Understand the differences between this one and the previous example. Previous example, package name, having several files within that package, defining the target file outside the scope of the package. As usual, right, you can go for compiling the individual package files if necessary. Then you can go for compiling and running the target file. Second case, we are defining the package files, right? Within that folder, and the main method has also been returned within that package as a part of package. So to compile and run that return, you try to use this way, compiling the independent class files using java c minus d space dot class name dot java option, then compiling the target file using java c minus d space dot space main class dot java option. Then finally, at running the file target file, we need to use the corresponding subpackage folder, subpackage name. So Java, the syntax, where is that? Here, Java subpackage name dot the main method a class name. Hope you understand. In the next example, right? For example, oh, okay, need not close, should not close. Consider the second package, right? The first package consists of three classes and one main class. The second package, I defined right three Java files. For example, for simplicity, I already run the code, so let me delete the corresponding bytecode files. You can understand easily. Second package defines how many classes. Second package class one package name is second package. Like first package, three classes are defined in the second package. Only thing the word first is replaced by second, right? So second package class one. This is second package class two. Then second package class three. Three classes are defined. One more file I need to open. First package class one, class two. Unexpectedly we closed, right? Class three. 1 minute. First package class three has also been opened. Okay. Now coming to this, ignore the main method right now. First package consists of three Java files, right? And ignoring the bytecode file produced, right, in the previous one. Second package defines three class files, individual class files. In all of these individual class files, what is the first statement? Package, second package. Package, second package. Here also, package, second package. Then package, second package. So two packages we are defined. One is the first package and one is the second package. Each package consists of package consists of find a target file by importing these two packages outside the scope of these packages. Right? Let me repeat. We do want to define one target file that imports the first package as well as second package, and the file should be defined outside the scope of these two packages, that is outside the scope of these packages, right? So here first package is defined, here second package is defined outside the scope of the package. Let me delete this. That's fine. Okay, outside the scope of these two packages, one package say access first second, sorry, one file access first second package Java file has been written. Understand? This is This is a target file. The target file which imports two user defined packages. One is, where is that? Yeah, where is that? Yeah. One is importing the first package dot star. Entire classes in the first package are imported. And another one importing the entire classes in the second package. Right? The file has been returned outside the scope of these two packages. We are directly importing the contents of these packages by importing the relevant statements. Next, what is our class name? Class name is access first second package dot java file name. So class name is class access first second package. Within this main method, since we have two packages, first package and second package, and each package consists of three classes, right? So those 3 plus 3, 6 classes are accessed here, right? Simply, right? Just to test how multiple packages are imported in a single Java application. How to import multiple user-defined packages in a single Java application. So for that purpose, simply I have defined the statements. First package class one object one is created, and the corresponding method in which, right, which contains the class one is called. Then first package class 2 object is created and the corresponding method which is defined in class 2 is called. Likewise, the third class in first package, right, object is created and the corresponding method is called. This is the creation of first package class 1, class 2, class 3 objects and calling the relevant methods. Likewise, here I have done creation of the second package objects, right, corresponding to class 1, class 2, class 3. Say object 4, object 5, object 6. Then the relevant methods available in these packages, that is these classes, right? Say second package, class 1, class 2, class 3 are going to be called relevant methods are called. Understand? Now, what is our target? Target is running the file, access first second package, right? This is our target. So as usual, as we done earlier in the first method, defining several classes inside one package and accessing the target file outside the scope of the package. Likewise here, two different packages are defined and the corresponding target application has been written outside the scope of these packages. Shall we try compiling the file access first second package directly? Let us try. For that, what we have to do? Where is our target file? Target file access first second package dot java is defined in the folder packages, that is defined outside the scope of first package and second package. So come one step back, compile the file java c. What is a target file? Target file is access first second package java c access first second package dot java. Nice, right? So without compiling the individual files in the packages, say first package and second package, we are directly compiled the target file access first second package java. Automatically the Java compiler compiled the individual classes in the entire packages that we are imported. Say first package and second package. Entire classes in first package and second package are compiled first, and then, right, the subsequent compilation has been taken place. So in the compilation time, right, there are some errors. What are the errors? In first package class 1, the class cannot be accessible outside the package because now we are violating, right, the default access scope. Default access scope means defining the package, right, a target file within the scope of the package. That is a default access scope. But In the target file, access first second package, say first package class 1. This is actually defined in the first package, in which the access specifier has been set as a default one, a default access specifier. So default access specifier in the sense that the content of the package can be accessible only with respect to the same package, only within the same package. But unexpectedly here, we do like to access the contents outside the scope of the first package. In that stage, here what we have to do means we need to define a public access specifier. Public control C method also public. First class has been saved. Then first package class 2 public. Here the method is declared as public. Saved. Then first package class 3 where is it? Here. Class is declared as public one. Method is declared as a public one. So save, cancel, save. For the second package, no problem. I think the access specifier public has already been set, right? Public. Now the files are saved properly. Let us try to compile the same target file access first second package dot java. Java C access first second package dot java file has been compiled successfully. Now let us run the file java class name. It's a class name access first second package. Access first second package. So we are seeing the result, right? Java access first second package. What we have called package 1, class 1 method 1, class 2 method 1, class 3 method 1. So package 1, class 1 method 1, class 2 method 1, class 3 method 1. Then package 2, class 1 method 1, class 2 method 1, class 3 method 1. That is, we try to write all of these, accessing of all of these 6 classes defined in the first and the second packages respectively. So here write second package class 1 method 1, second package class 2 method 1, second package class 3 method 1. This is a way of writing user defined packages. So concluding, right, package is nothing but a collection of classes and interfaces. We can define our own user defined packages in Java. To do that, you need to create a folder, and the same folder name, right, should be used, right, for the package name, where the package file, right, should have the package statement, package name should be same as the folder name. Within that folder, that means within the package, you can have any number of classes. If possible, you can define the target file outside the scope of the package, and we can run the target file, compile and run the target file directly. If not, we can compile the individual package files and then go for compiling the target file and running the target file. In some cases, right, if you want to access the main method, that is to be put inside the same package, right? So that stage, it is better to use java c, this option, right, minus d dot minus d space dot space a class name dot java. So this way you need to compile the individual files and ensure that the bytecode files are put it in the separate directory, and then to run the required Java application. In this case, use Java C, same thing, same compilation, and to run that, right, use the folder name first. Java folder name dot main method class name. This way you can run the files, the main method file, which can be defined inside the scope of the directory. So anyhow, right, you need to ensure that the corresponding bytecode file should be produced. Here also, right, in first package, after our compilation, uh, by importing the first package and the second package into this target application, it created the corresponding bytecode files which are listed here. Likewise, second package bytecode files are recently created by 335. The recently created bytecode files are listed out here. Only thing, accessing the files within the scope of the folder, there you need to define the main method within the scope of the package, within the scope of the folder, by writing the same statement that import package name dot import package name package name semicolon. There you try to use this option java c minus v space dot space file name dot java option, and ensure that the bytecode files are going to be created in the separate subfolder. Then only you will be able to run the required Java application, which is a part of the same package, right? This is very important. Hope you understand, right? The accessing rules of packages, how to define the user-defined package, and how to access the package. Now let us summarize the accessing rules of packages, accessing rules of classes and objects with respect to package consoles. You try to include right the protected access modifier also, right? Having the access specifiers private no modifier, that is a default, protected, and a public one, having these four access specifiers private, a default, protected, and a public. The thing is, with respect to inheritance and without inheritance, we have these classifications. The instance variables, methods. How can you access the class, instance variables, and methods inside the same class, or subclasses in the same package, non-subclasses in the same package, and subclasses in different package inheritance without any inheritance in different package. That is non-subclasses in different packages. So coming to this, right, we have already explored the default access specifier. Default access specifier is public with respect to the same package, right? Same package means inside the class, no modifier. Access specifier is accessible. You can access no modifier instance variables methods anywhere within the same class. And subclasses in the same package. You can perform inheritance. Of course, right, we didn't apply inheritance right in our classes, in our case, in our examples. You can also write inheritance. For example, first package class 1 and first package class 2. What you have to do? Class public class first package class 2 extends first package class 1. That is possible. So with respect to the same package, subclasses can access a default access modifier, default access instance variables and methods. Non-subclasses in the same package, right? No inheritance concept. Any class in the same package can access the default access modifier. With respect to our example, right? The main method accesses the first package class 1, class 2, class 3 files without any inheritance. So first three categories, right? The access specification is yes. Subclasses in different package. If you say different package, like when you come out of the first package, any content of the first package cannot be accessible directly in the default access code. No modifier access code. So subclasses in different packages or even non-subclasses in different packages or general different packages cannot access the default access modifier, default access instance variables or default access members. This is a rule of a default access. Then private is concerned, right? Private we already explored. What is the rule of private? Private members can only be accessible within the scope of a class. Simple rule. Private members, private instance variables or private methods can only be accessible within the scope of the class. That's all. So inside the same class, private instance variables or methods are accessible. When you come out of that class, right, private is hidden, right, data security property, data hiding property. So for all these four categories classification, you have to put no. Private variables cannot be accessible outside the scope of the same class, right, outside the scope of the class, right, that is okay. So private root is okay. You understood, right? The general rule of a default access receiver. Then coming to the last one, right, to public one. Public, right, it is very easy. When a class member, right, is declared as public one, that can be accessible anywhere within the same class or anywhere within the same package or anywhere within or anywhere outside the scope of the same package or even in different packages because the access specifier is declared as public one. Inside the same class, public instance variables and methods are accessible in subclasses or non-subclasses of the same package or in subclasses and in non-subclasses of different packages. Public instance variables, public methods are completely or public classes are completely accessible. Classes, instance variables, methods are completely accessible with respect to public access specifier. Protected, we already said, right? I already said protected can have a significant, right? With respect to inheritance, right? So protected in the sense that in the same class, right, protected members can be accessible. In the same class, right, whichever is a private, no modifier, protected or public is accessible. Then with respect to the same package, a protected rule is okay. Same package subclass, the same package inheritance, same package without inheritance. Protected access specifier is okay. But subclasses in different packages, even protected is okay. But non-subclasses in different packages, in that protected access specifier or protected members cannot be accessible. Right? So you try to learn this way. Private, general, that is default, private, default, protected, public. Private, right, I will try to remember these classification. Inside the same class, sub package, same class, same package subclass, non subclasses in the same package. Subclasses in different package, non subclasses in the different package. Right, private, put only one yes, one, then no modifier, 3, right, 1, 3, and this is 4, 4 is, and this is 5, right? So try to remember the rules this way. 1, 3, 4, 5 is remaining entries are made as rows. These are the accessing rules of classes in Java with respect to package concepts. So try to go through these examples, and if you have any queries, you can ask me. I will clear your doubts. Thank you very much.